So what we want to do now is take some of those techniques and put them into a slightly more complicated program that's going to move a bit more towards what you're going to be expected to do for the assessment. So I've got a simple little program here. I've got two text boxes, one for input, one for output, and then I've got a selection of buttons representing different vegetables and fruits along here. And the idea is you'll put in the number of an item you want to buy, you click on the type of the item, and it will tell you the price. Simple enough. Let's have a look at the code. So this is my broccoli button here, and I've put the code in already, and I'm going to do a number of things. So first of all, I want to tell it what the price for one bit of broccoli should be, but I've already run it into a build error. And if I look at the build error, it says literal of type double cannot be implicitly converted to type float, you blah blah blah. The problem here is that C uses doubles to represent decimals as a default. And when I say 0.8, what I'm really saying is a double called 0.8. Sorry, a double with the value of 0.8. Even though I've said this is going to be a float, it's still saying, well, this is a double value. I can't stick that in a float. There's not enough space. So to get around that, we just put an F at the end to tell it to treat that value as a float, to keep it as a short bit of memory. Now, there are some problems with using floats as currency. So when you start to multiply them a lot, when you start to add a lot of them together, because floats are quite a short memory space, they're quite limited in the amount of data they can hold, there are rounding errors built in. They're not quite exact. And as you add lots and lots of them together, or you multiply them together, you end up with those errors building up and increasing as you add more things together until they start flicking over. You get an extra penny on or whatever when you didn't want it. So if you were doing like an accountancy firm's accounting software, you would not use floats. In this case, it's kind of okay because we're just doing one calculation, and it's not, the rounding errors are never going to end up in that calculation. But that whole thing about, Superman 2 stealing the pennies off, this is where that kind of stuff comes from. Using data types that don't have enough memory to accurately represent the number that you're actually trying to put in there. But as I said, for now, we'll just use a float. It saves us some memory as well, and for a very short program like this, it's not going to be a problem. So I've got my float there. I'm going to say 0.8 for the broccoli, so 80p, and then I've got my pass, so I create an integer called value in this case, and then I've got my if statement. If it's successful in passing textbox1.text, store that value as value, store that number as value. So try and pass whatever numbers in textbox2, store it as value. If you are successful, because I've got no exclamation mark at the start now, so if that's successful, then I'm creating a new float called total. I'm assigning it the value of value times price. So value was the number that I got from the user, which should be an integer, a whole number, and I'm multiplying by price that's a float. Now you might expect it to spit its dummy out again here and say, well, value is an integer, and I'm multiplying an integer by a float and then try and store it as a float, and that could be wrong. What happens is if you multiply or add together two different data types, it automatically uses the larger data type. Whatever takes more memory and can store more numbers, store more values, is the one that's spat out. So in this case, if I'm multiplying an integer by a float, the float has more space to store data, so it will default to making that whatever that number comes out as into a float. So there I'm fine with just using float total equals value times price. If I was trying to get an int out, I'd have to do some clever stuff and convert it back, because it would say, oh, well, it can't store this much data as an int. I'm then going to spit it out into textbox2, but I've used a slightly different method of producing the string from the float in this case. So what I've used, instead of doing convert.toString, I've just done the name of my variable, so total, and then .toString. Now, these aren't, magic words that cause computers to do things. These are all defined up in the libraries. Somebody's taken the time to write out how these should work, how you should do a conversion from a string, from an int to a string, from a float to a string, from a double to a string, etc. And they've come up with basically two different methods of doing it. They've got the convert class, which would handle it one way, and they've got this toString method that handles it another. Convert is more powerful than toString. It handles exceptions better, and it does a number of things better, especially handling null values of your integer. So if your integer hasn't been assigned, Convert can cope with that. toString will crash your entire program. In this case, we already know we've got a value in that float, so we're fine. And the big advantage is it allows me to compress down my currency conversion, which is this quote marks C quote marks inside this bracket after toString. That tells it to format it to be a currency. Now, if I'd done convert.toString, I'd then have to take that string and format it using format string. If I do it this way, then I don't have to. So it's just a little shortcut to save me a couple of lines of code. The C here says this is a currency. It doesn't specify which currency. So in this case, it will use whatever the computer thinks it should use. And my computer is English, so it has sterling set up as its default currency, so it will put it into sterling. If you were in France and you ran exactly the same code, it would produce it in euros. If you were in the US, it would produce US dollars. We can specify which currency we want, but again, that requires some more code that I don't want to be writing right now. We'll come on to that. So that's handled the taken the number that I'm given from the user, it's multiplied it by the price, and it's put it as a total, and then it's spat that total out as a string. Otherwise, you know, a standard message box show, please enter a whole number. You type something in that I don't understand. So let's run that and see if it works. So let's do 12 bits of broccoli. Should come out, yep, to £9.60. Let's just try 13, £10.40. So it's going up by 80p each time. So that's pretty much the effect we wanted to achieve. Now what we need to do is make the other buttons work. Now at the moment, what we'd have to do is copy all of this and paste it into every other button. The problem with that is I'm going to end up generating huge amounts of code to do the same thing for each button. And I don't really want to do that. So what I'm going to do instead is create a function. So I'm going to make it modular. I'm not going to try and do the same thing over and over and over again in the code. I'm just going to say do it once and here's where to do it. So what I'm going to do is I'm going to create my own void down here. Let's just uncomment that so we can see it properly. And it's got the same code in it. It's just put it in a different section of the code in this private void. So it's a void because I don't need a return from it. And I've called it calctote, and then you just put these brackets on the end, and that's your function defined, and then you have your braces that contain the code. The brackets here would contain arguments, but at the moment they don't because I'm just keeping it simple for the moment. We'll go on to look at adding arguments in a minute. So here's the code, does the same thing. So if I try and run that, I'm going to hit some build errors again. And the build error I'm going to hit is the name price does not exist. So our variable price, which we have, I haven't declared. So let's take the comments out of that so that we still assign that on our button, but I'll still get the same build error. So it does not exist in the current context. The reason for that is even though I'm creating that float inside that button, it only exists inside that void. As soon as I get to the end of that void, that memory space is blanked. So this only works inside this section. So when I want to call it somewhere else, I can't get to it. Let me put that back because I've got it down at the bottom. So what I'm going to want to do is have that variable available throughout the program, not just in that single void there. So to do that, I need to declare it up at the top here. So inside public partial class form1, which contains all of the programming for form1. So let's call float price. I'm not going to assign it a value at the moment, I'm just going to declare it. So now you can see that build error has disappeared and I now can multiply it by the price. So I've now got code that works for my my own function. The problem I've got is I haven't called it yet. So to call it, first of all, I'm going to I've mucked that up. There we go. First of all, I'm going to assign it a value. So I'm going to put 0.8f into price. I don't need to have float price anymore because I've declared that it's a float up here. That's fine. And then I'm going to call my function. So calctote bracket bracket semicolon will then call my function. So that should then, when that button's pressed, assign that variable that I've stored from the start a value of 0.8 and run this function, which should calculate my total. So let's hit F5, just check it works again. Yep, it's spitting out £9.60 again. The big advantage of getting there is instead of writing all this code over and over and over again, I can now go to each button and I can just give it a different price each time and call that function again. So if I now hit F5, do 12 cherries, I get £6 out. So it's given it a different value for that price, which is used here, but it's running the same function over and over again. So that significantly simplifies your code. You've now got one modular block that's being used over and over again, one function that's being used over and over again, rather than the code written 50 different times through your program. And that's one of the great advantages of programming procedurally. Okay, let's leave it there. We'll come on to make some improvements to this code in the next video.